Hello guys, and this is my first video probably for my channel, and I will be training a YOLO model from scratch. We will be mainly focusing on data annotation part and how those pipelines work, because what I am here for, because there are many people who are making videos regarding fine tuning the models and making sure that everything goes well, and regarding the fine tuning and training a particular model for a particular case. But for me, we are right now focusing on training models. We are focusing on training models and preparing their data sets. So right now our main focus will be YOLO, an object detection model. I'm starting with first video. It will be a little abrupt. You can skip where you would like. I will try to make sure that there are terminals where like pointers where you can skip the video. And the first video, our main focus is, number one thing is, we will assume that we have no data. Okay, and we have no data. That means we have no annotated data with us. Annotated data. And number two is, basically we have to train the model and get the .pd file. Okay, so this is our main two goals. And number three, let's say we have to run inference. We have to run inference on, let's say, a video of a particular scenario. So number one question, when given these particular scenarios, the first question that arises is, what are we trying to predict? What are we trying to predict? Okay, so we are trying to predict, like, the answer to this particular question is, we want to predict that bananas, let's say we want to predict bananas. We want to predict bananas. So how whatever way you want to write them, you want to predict bananas and a given picture. I have not yet prepared the data, but I will make sure that we cover multiple classes, so you have an idea how we will do the labeling part, and after that how we will be training the model. Okay, and we want to predict the bananas in a given picture, not the number of bananas, but we are just trying to predict where the particular banana is. So for that we have, what kind of data. The next question is, what kind of data do we have? Okay, so we have hundreds of pictures of bananas. Sounds weird, but it is what it is. Okay, so yes, to do this, answer to this, and yes, hundreds of pictures of bananas. And after that, now we can start working. So the thing is, now we can start working. We have to go look for our data, and yes, I will cut through that and show you the data. So basically there are 141 folders of multiple fruits in this particular data set. So what we will do is, we will just simply be using fruits that of our use, that satisfies our case. So we'll use this apple, not cantaloupe. We'll go for apple, banana one. There are 490 images of banana. Okay, this is weird. we have same type of bananas. Okay, that is not what I would have liked, but okay, this is not something that is very ideal for me, I guess. I was assuming there will be multiple kind of images, multiple types of fruits in one particular image, but okay. As I said, it was an image classification data set. This was stupid of me to think that they would have multiple kind of images, but yes, let's get over that. And we just create a new task here. Name the task as banana. Banana. Okay. And we will associate it to the project. And after that, we'll just drag this whole folder into this. These are 490 images that we are going to annotate. Okay. Submit and continue because will not create task network error. It is a bit weird. But let's try this again. And yes, we just submit and continue. If we go towards the next fruit, that is apple, I guess. They have used the image classification approach. I'm going to like this. I will do this for the whole for the three different classes. Okay. The reason I'm making different data sets is different tasks is because when we are working with multiple classes and we have data segregated as we have right now, it's easier for us to just label one class with one data set. This will help us balance the data set somehow, but that is something we don't have to worry right now. So I'm stopping the video here and will continue after I created all the tasks and everything. Let's meet soon. So the task has been created and now you can see we have three classes and three particular tasks. And yes, we'll start labeling from here. And yes, we'll go with bananas first. And it is not the ideal choice of dataset that I should have been using, but maybe I will delete this video in future, but you never know. What we will do here is we know that a banana is going to be in the center, or sometimes it is going to be in a different location. We'll just try to make sure that for all the horizontal bananas we have a different type of box, and for different type, basically what I'm trying to say is that we will drawing box tightly and making sure that none of the data is lost. So basically in an ideal scenario I would have tried to go with an instant segmentation model, but that is for another video and we'll keep that in mind with this particular data set too. But yes, what we will do here is we will draw one box, and the next thing we'll do is propagate. It will propagate on all the frames. Okay, and this what I can do is I can just set the whole data set, the whole box, and tighten it up to the banana. Okay, so this is particularly a boring step in the course. Okay, I will just complete it and get back to you. Okay, thank you. This is something that you have to do for all the cases, right? For the bananas, for the apples, and for the avocados. And yes, thank you. We'll get back. Is annotating the whole data set, and I wanted to add a few things. Sometimes data set annotating a particular data set becomes very hectic. For that, you have to outsource the data set, and if the data is not very like you don't have the problem with privacy, you can outsource it. But if the problem is that you cannot outsource it to some country like Pakistan or any other country that is much more cheaper than US or any other country, like from like it's basically an export kind of thing, no? In my opinion. Again, this is my opinion, and yes, you have to make sure that all your databases and all your annotation tools are secure somehow. And for that, you have to work pretty hard. like making sure that all your annotators are happy at all times, they are getting their guidelines, they are like considerate with all the requests, like you are being considerate with all the requests that are being made from on their end. And yes, it is very hectic sometimes, but it is very necessary, so please make sure that you do that, and things will be much more easier for you guys. Okay, so let's meet you when I am exporting the data set. So basically, I like, get back to you now. So welcome back, and we have annotated the data set entirely with object detection, and we have, as I've told you, we have three classes: bananas, apples, and avocados. And yes, now it's time to extract the dataset. We'll just go here and we'll export dataset in our useful, that is YOLO v1.1. Save the images just for the sake that we don't have to again download them in some form. We'll name it as fruits dataset. We'll just it will just extract all the images from the DB and just set them up for us. For that, now it's downloaded here. You can just simply download it here, and yes, it's 6.61 MB of data set. That is not very big. So let's see. So basically we have an image here that is very small, 100 by 100, and for that we have our annotations. That is 0, and it is multiple annotations that are being created. I don't know why that is. I guess that was a bug. Let's see. It's okay. Okay, we figured this out. We'll just correct it manually. Sometimes it does make some mistakes. And we'll just save it this way. Pretty bad, that's why I just left the video. And yes, we are going to extract this into another into another folder. I guess it's completed. The reason it's happening so fast is because it's a very small data set. Once we are working with big data set, it is going to take some time. And yes, let's see what is happening here. It's saying that it is labeled multiple times. Let's just correct that. So this might be the case because I was, oh yeah, okay. You can see for each image, it has a corresponding manually labeled 0.500, 0.500. That this is basically are the coordinates. It is showing that it is on XY. X is 0.500 and Y is 0.500, and the width and height of that particular box is 1 That means the box covers the whole image. It is in normalized form. Again, the reason the YOLO is very efficient is because there are multiple in the annotation. The reason the YOLO is very successful is that it is very lightweight, and again you just have to, this is our class, 0 is associated with bananas, and you may ask, how do I know that 0 is associated with bananas? I'll just go here and okay, sorry, I will just go here. It tells me this is basically a data file. This tells me that there are three classes, and the path to all the txts are in the training txt, and backup is backup. I don't care about the backup, and this is the object.names file. This tells me that for each label, 0 is bananas, apple is 1, avocado is 2, 0, 1, 2. Okay, we'll just save it. I don't know, I think I said 1 is for banana, but 0 is for, like, it will go like this. Let me write it here, 0 and 1 for Okay, I'm sorry. One is for this and three is for this. Okay, two is for this. I'm sorry. And I'm not going to save this, but this is just for your understanding that that it we just make sure that using that object.names file, it tells us that bananas is the zeroth label. So while working with Python, you should know that Python takes the starting index from 0, so 0 1 2, and we have three classes. So the first class will be 0, second will be 1, and the third will be 2. Okay, that is a bit confusing, but when you will work yourself you will figure it out. Okay, so I have created a few scripts that I am going to use. These scripts are not for this particular project, these are for multiple projects that I work with. Okay, activate. Okay, I just yes, and I just start with Jupyter Notebook here. It will open up the Jupyter Notebook for me. These are some of my projects, and now I guess you have to go towards the downloads. This is dataset preparation file. We can name it whatever you want, but it was for a particular project. Let's moving on. We just need to split these into train test format. So one thing that we need to learn here is that YOLO dataset is in three forms: images, number one with txts in YOLO format, W, H, Y, and X. The first video, I guess it is pretty bad, but I guess you are understanding what I'm trying to do here. Image and its txt. Okay, in this particular format, and here is the class number, whatever class it belongs to. This is what we want, and this will be in three particular folders. Okay, let me get my tablet so I can write better, and just give me 1 or 2 minutes. I will now on my writing would be a little better. And this is the first. Let me tell you an interesting thing. I was, watching a motivational video, and I just figured out they said that if you wait till you are ready, you will be waiting for the rest of your life. So yes, I didn't wait much, and I started my own page, and today I established everything, and today is is the first time I'm going to upload the video, so it is a bit interesting. So yes, so what we have is we have an image, we have a txt, and we have the txt written in this format. This is basically the class ID. I'm going to say it. Okay. And what we want for the model training, we are going to use YOLO V8. It takes data in a form of, we have a data.yml file, YAML file extension. I will show this format, and the images are distributed in these particular format. Like we have three folders that are train, test, and valid. Okay. Okay. So for each folder, there is a folder name called image and a label. Okay. So I guess you know what image means and what label means, right? And I'm not going to go in depth of class balancing and everything. I'm just trying to show you how you can do the model training from scratch. Okay. So yes, this is some things that you are. And now what I'm trying to do is that I have a folder. I've written a script that has that will go take a folder name and figure out for each image, find the txt, and randomly move it into one of these folders. Okay, train, test, and valid. Okay, the distribution I have given that in the script. Don't worry about the scripts, they are They are in the they are in the on my GitHub page, and hopefully I will upload them soon. But for now, I can show you the script. This is the script. It will take the dataset here and output directory here. Okay, and yes, we are going to give this particular directory to the script as dataset. Okay, I thought copied it with Control Shift C, but I didn't. And for the sake of learning, I will just you know get the dataset here. Okay, we'll write the name of it as dataset fruits. It will create now. What it will do is it will create a folder called dataset underscore fruits, and in which in that we have three different folders. Okay, let me show you. We'll just run the script, and here it is. Test, and let me show you the split. The split was 70-20-10. Okay, and yes, you might have some data loss here, but it is negligible. The reason it is negligible is because, and the reason it is negligible is because it's 0.00001. It is funny when I say it like this, but yes, it is true. And yes, we have to go here and we copy this dataset YML file, and we just paste it with the original dataset that we with any dataset we are trying to prepare. Okay, we can just go here and paste this dataset data underscore car YML file. We'll just edit it. We'll write it as fruits. It will just save. We'll open it. It will open it in Visual Code. We'll just delete all of this. We'll change the number of classes to 3. We'll write a script here. We'll write a list here. Banana. First class is banana. The second class is apple, I guess. The third class is avocados. Avocado. Okay. I guess it is avocado. It is avocado, but I'm just trying to make sure the spelling are same. Avocado. Okay, they are same. So it doesn't matter the spelling are same or not. The reason is that, let me just save this, and the reason is because it wouldn't make a very big difference, honestly, because the computer itself, the model itself is working with 0, 1, and 2. Whatever we want to name them is very secondary. Okay, we'll just save this and we'll just go. Okay, this is not important. We just go to now the dataset is prepared. Okay, now I'll just run the simple script that I have created. I will go into mini anaconda activate YOLO V8 underscore 1. Okay, CLS, and just figure out where the script is. I'm sorry, it is my first time doing all this, and I'm very much excited about doing this. Yes, this is the script I'm going to run, and I'm just going to change one thing about this script is this is a very basic script. The reason I'm using torch.multiprocessing is that my laptop GPU sometimes gives an error if the GPU is busy with some other functionality, so it just invokes the multiprocessing. Okay, and we'll just do is go here, the fruits dataset. No, not here, but we'll just copy the path of this fruit. We'll just copy the path of this folder and paste it here. Okay, the model is going to run for 100 epochs, let's say, and the image size will be stretched to 640 by 640. Okay, batch size is 16. And yes, this is, I guess, stretching the image this big is not the right idea. But yes, I'm going to save the script. Copy path. Okay, it's going to run Python shift insert. It is using a pre-trained model, and it is going to download that pre-trained model. You can update this in settings.yml. It is not able to look. Okay, let's figure out what this error is. It is saying that file not found error. So basically what I'm giving to the data.yml file is, no, the dataset download directory is, okay, you can update this in settings.yml. So I'm not going to give the, basically I'm giving a very relative directory to the data underscore fruits.yml file. Now what I will do is I will give the absolute path here. Okay, absolute path might help, I'm not sure, but it might help in figuring out where the data is. Okay, to the it might help the model figuring out where the data is. Okay, so yes, and again your feedback is very much welcomed, and if you want to troll me on how I try to speak and how my English is, it's not a big problem. You can troll me as much as you can. Okay, the reason I'm here is because I want to learn new things, and I want to expand what I want to give the society what I learn. I know. Okay, so let's train the model. I guess the error will not be this time. Yes, it's not giving an error this time. It is automatically removing the duplicate labels. Okay. Yes, new cache is created for the train label, and yes, let's see if it is using my GPU. Yes, it is using my 4070 laptop GPU, 8188 MB. I guess okay, it has done the same thing for validation. 281 images, and here it got around 986 images. Yes, that is interesting. So, yeah, I'm sorry, I shouldn't have. I will just shorten it here. I just wanted to plotting labels. It is going. The training is started. Okay. First video. I think I didn't save it, but yes, this is what we were trying. This is what our goal was. What are we trying to do? We want to predict bananas. Now you can change it to we are trying to predict bananas, apples, and avocados. Okay, in a given picture, what kind of data do we have? We have 100 pictures of bananas, apples, and avocados. Okay. So yes, we are going to save this. We have achieved our goal. The model is training. The mean average per scene is, I guess, not so bad. GPU memory is very little because the image size is very small, I guess. And mean average per scene is around 0.853. I guess it will go up and down. It's just 10 epochs. And if you have any questions, just let me know. I will I'm going to stop the video right here. And if you have any questions, just comment and subscribe. And thank you very much for watching. Okay. Okay. Okay, I will try to add a small part where I will do the inference using this PT file. But before ending the video, let me show you some interesting thing that will be in, like, when you will do it. The run folder is created, detect train under train 2. The name of the folder is train 2. Okay, I guess it is for another thing, I guess. Weird, but yes. Let's see what it said in the cmd command prompt. Here it is. Where is it going to save the files? It is going to save the files in runs detect train to label images. Okay, I think I was wrong. No, it is using fire. So I guess this is not the folder we are going to be working with. And yes, the folder might, so the folder is here, so you don't have to worry about that. It might be, let's see, train detect label underscore image. It is there, but I guess it is not showing us. Runs detect. It should be creating a folder like this, okay? And the folder is here, user Osama. The reason the folder is created here is because I ran the script in this particular directory. The script was called from that directory, but it was ran in C users Osama. Okay, that is why it is made here. And detect to. We'll just go see here. The distribution is like 600 bananas, apples are 4, and the 300 something, and avocados are like this. Okay. So yes, this is how we can see our distribution. I will tell you in other videos that we can do this in a different part too. Yes, I will add a small intro part where we will do what do we call inference regarding using these particular parameters. But for now, the results are pretty good, and the let's see what the results are actually. Mean average precision is of 0.846. That is pretty great, I guess. We don't have to worry about that. And yes, you have trained your first YOLO model object detection using custom dataset preparing using CVAT. Okay, thank you very much. And if you want to support me, I will add multiple links, and however you want to contact me, there is my email address. The model was trained and it gave us the best PT files. This is our results of our model, and yes, this whole folder is created whenever you run YOLO V8. And yes, you go here, you can just copy these PT file path and to this inference file here, and with that I gave it my test image. This was my test image. I ran the script and this was the results. And thank you for watching the video. And you will now be able to train a YOLO V8 model. And the reason the boxes are not very tight is because there might be some data points where the images are not properly labeled, and you have to make sure that during the quality control process. And thank you for watching the video, and I hope you subscribe. And if you have any questions, just comment down below and I will try to answer that.